So your construct understanding activity gives you 6 different equations to factor, but I'm only going to do 3 of them here. And it also asks you to find a difference of perfect squares and a perfect square trinomial. So I've decided that I'm going to have a look at this one, that one, and that one, and you can try the other 3 on your own. This one has a bunch of big numbers in it. As soon as I see big numbers, especially as soon as I see a number in front of the squared term, I want to see if I can factor that out, because that's just going to make life a lot easier. So the first thing I do is look and ask myself if there are any common factors between 3, 6, and 24, and 3 works for all 3 of them, so we're going to take that one out. I'm left with a squared minus 2a minus 8. So I'm just going to leave that 3 out for now, and I'm going to continue to factor the equation. Now that there is no number attached to the squared term, it's pretty easy. I'm just going to find the factors of negative 8 that add to negative 2. Remembering that when it's a negative, they have to be a negative and a positive, so it's actually a difference that I'm looking for, and there it is, 2 and 4. The biggest one has to be a negative so that that wins. So I'm just going to be making my sets of brackets with my a's there, my negative 4, and my positive 2 inside the brackets, and it's done. If I wanted to FOIL that and then multiply through by a 3 on everything, I can make sure that the answer is correct. So just really quickly, first is a squared, outside is 2a, inside is negative 4a, oops, getting my colors mixed up, and the last ones are negative 4 and positive 2 gives me 8. I can see that these guys are going to reduce to negative 2a because I've got a negative 4 and a positive 2. And if I multiply all these guys through by 3, I'll have 3a squared minus 6a, whoops, that should have been a negative. See? I caught my mistake because I was looking, well, I caught an internal mistake, but I caught a mistake. So I'm going to go 3 times negative 8 gives me negative 24. I look at this, I look at that, they match, we're good to go. So you can see the value of, every once in a while at least, going through, foiling out your answer to make sure that it goes back where you started. This one's got a bunch of big numbers, but I've got nowhere to go with them because 9, 12, and 4 don't have any common factors. 9's only factors are 3, and that doesn't work for 4. So we're going to have to look at something else there. This is where decomposition comes in. And decomposition is a little bit trickier, but it's a very useful tool. So in decomposition, I'm going to go 9 times 4 gives me 36, and then I find the factors of 36 that add to 12. Fortunately, everything's positive, so that's not a big deal. 36 has a lot of factors. Whoops. So I have to figure them all out, and if I add them up, there's one that adds to 12. So I'm going to rewrite my equation now using those middle terms. So you can see that this looks like first, outside, inside, last. And that's exactly what it is. We're basically going backwards saying, okay, I combine these 2 middle terms in order to get that. So now I'm at the spot where I've multiplied my first terms and my outside terms to get this one, these ones, and then my inside and last to get those ones. So I can just actually make a little point of writing that. Just go first, outside, inside, last. Those are the terms that resulted from those multiplications. So basically what that means is I should be able to factor something out of the first two because in FOIL I multiply the first term by the other two in the second set of brackets. So I'm going to look at these ones and look for common factors. 3 is a common factor. B is also a common factor. So I'm going to now go 9b squared divided by 3b would still give me a 3b. And then I look here and go 6 divided by 3 is 2. B divided by b, that's just not going to be a b. And then I look at the next set of brackets, or sorry, next set of terms. And these would be my inside and last. So those would be the ones that I multiplied by the second term in the first set of brackets by everything in the second set of brackets. Don't worry if you don't follow that. It's not a big deal. So 6 and 4, it's positive, so I put a positive here. 6 and 4 have a common factor of 2. 6b divided by 2 gives me 3b. 4 divided by 2 gives me 2. And that's when I'm going to look and see if my brackets match. The brackets have to match. 3b plus 2, 3b plus 2. So what I'm going to do now is I'm going to take this term and this term, and I'm going to put them in their own set of brackets, like that. And then I'm just going to use the matching set of brackets like that. Now you probably noticed that they're the same. 3b plus 2 and 3b plus 2 are the same. So this is a perfect square trinomial. If the brackets match, it's a perfect square. I could have just written it like this. Right? So that's what they mean by that. Next one we're going to look at is m squared minus 16n squared. And it looks weird, it's not a trinomial, and you should notice right away that it has that beautiful little pattern of being a perfect square minus a perfect square. So right away, before we even do anything more, we know that that is a difference of perfect squares. And the reason why that's so fancy is that I can just simply set up my brackets, take the square root of that one, minus plus, take the square root of that one, and I'm done. Now if you need to see that foiled out to make you understand that it worked, then we can do that pretty easily. M times m is m squared, plus 4mn, minus 4mn, use the alphabet to determine order, minus 16n squared. These guys are going to cancel out, and we're left with m squared minus 16n squared. Difference of perfect squares. Your book loves it. You should be very familiar with it.